Today we'll talk about the quadratic formula. So I actually wrote it out here. If ax squared plus bx plus c equals 0, very important that the equation is written in this form. With a not different than 0, a, b, c real numbers, then the two solutions that the quadratic equation has are given by these formulas, negative b plus square root of b squared minus 4ac and negative b minus square root of b squared minus 4ac. So basically you can comprise it into only one formula. The solutions are negative b plus minus square root of b squared minus 4ac, everything over 2a. Very important, it's a long line and it's over 2a. So I chose here 3 examples to solve using the quadratic formula. I would advise you when you solve quadratic equations using quadratic formula to actually write that formula every single time. That way you will remember it. So if we try to solve first example 1, right? As you can see, it's not written in that form that we originally had, like ax squared plus bx plus c equals 0. So let's move this 4x on the other side and let's move the 1 on the other side. So on the left hand side now we have 2x squared minus 4x minus 1 equals 0. Now the equation is written in that standard form where a is the number in front of x squared, b is the number in front of x, and c is the constant. So a equals 2, b equals negative 4, and c equals negative 1. So now the solutions, which are two numbers, and I'm going to write x1 comma 2 because there are two solutions. I'm going to write the formula first, negative b plus minus square root of b squared minus 4ac, everything over 2a. And now I'm going to start replacing. So negative b, 4, because it was negative 4, plus minus square root of negative 4, everything squared, minus 4 times 2 times negative 1, everything over 2 times 2. So it's 4 plus minus square root of 16 plus 8 over 4. So it's 4 plus minus square root of 24 over 4. 24 can be written 4 times 6. So I can say, so 24 can be written 4 times 6. So I can do 2 square root of 6 over 4. As you can notice, the numerator can be factored, the 2 can come up, plus minus square root of 6 over 4. This 2 and the 4 cancels, and we end up with 2 plus minus, 2 here, 2 plus minus square root of 6 over 2. So there are two solutions, 2 plus square root of 6 over 2 and 2 minus square root of 6 over 2. So there are two real solutions. Let's solve problem 2. So again, problem 2 is not written in that standard form. So I am going to add 6x to both sides. And I'm going to make sure the terms are in order. 3x squared plus 6x plus 5 equals 0. So the x squared term first, x, and then constant. So a equals 3, b equals 6, and c equals 5. So x12 is negative b, so negative 6, plus minus square root of b squared, so 36, minus 4 times 3 times 5, everything over 2 times 3, 6. So it's negative 6 plus minus square root of 36 minus 60 over 6. So it's negative 6 plus minus square root of negative 24 over 6. Interesting, right? In the previous problem, we got square root of 24. Now we have negative 24. Well, if the question says find the real solutions, you would stop here and say no real solutions because of this negative 24 under the square root. But if it says find all the solutions, that includes complex, so we can move further and say plus minus, this negative comes outside as an I, and square root of 24, we already simplify that into a 2 square root of 6, everything over 6. So I can factor out a 2 from the numerator, so it's negative 3 plus minus I square root of 6 over 6. The 2 and the 6 cancels, and we get negative 3 plus minus I square root of 6 over 3. So basically, we do have two solutions, negative 3 plus I square root of 6 over 3 and negative 3 minus I square root of 6 over 3, but this time they are complex solutions. And the third problem, I'm going to add a 1 to both sides, so x squared plus 2x plus 1 equals 0. So again, A is 1, B is 2, and C is 1. So x12 equals negative b plus minus square root of b squared minus 4 times 1 times 1, everything over 2. So it's negative 2 plus minus square root of 4 minus 4 over 2. So it's negative 2 plus minus 4 minus 4 is 0, square root of 0 is 0 over 2. So we actually end up with negative 2 over 2, which is negative 1. So in this case, the two solutions are just one solution, which is negative 1. So let's have a discussion here. If you look at the number under the square root, in one case we have 24 and we got two real solutions. In one case we had negative 24 and we got two complex numbers. And in one case we had 0, so we got only one solution. So basically b squared minus 4ac, which is called the discriminant, so b squared minus 4ac, which is called discriminant, it's actually telling us how many solutions our problem has. So if this discriminant, let me call it delta, is less than 0, then we have two complex solutions. If delta is equal to 0, the discriminant, or the b squared minus 4ac equals 0, we have one real solution. And if delta is greater than 0, if b squared minus 4ac is positive, we have two distinct, different, right, real solutions. Okay, and one more thing regarding quadratic equations. So the other thing that I want to discuss with you is writing quadratic equations from solutions. So basically, let's go backwards. Let's say the equation has the solution 3 and 5. I know that x equals 3 is a solution and x equals 5 is a solution, and I want to find the possible quadratic equation that can have those solutions. Well, let's think about it. If x equals 3 is a solution, x minus 3, it's a part of the problem, right? It's a factor. If x equals 5 is a solution, x minus 5 is a factor, right? Just imagine that you are setting each of these equal to 0. If you set x minus 3 equal to 0, don't you get the 3? If you set x minus 5 equal to 0, don't you get the 5? So if you multiply these together, you are actually getting x squared minus 8x plus 15, and this would be one equation that has a quadratic solution of 3 and 5. One more. Let's say the solutions are negative 7i and 7i. The question is, what's the equation? So again, x plus 7i, right? It's a factor of my equation, and x minus 7i, it's a factor. Well, if you multiply this, you get x squared minus 49i squared, which means x squared plus 49. This is an interesting example because it's actually telling us that you can factor out x squared plus 49, but only in complex numbers. I hope this helps.